Section 5, Chapter 9, Section 5 is talking about graphing tangent and cotangent. We did sine and cosine. Most of you did really well on that on the test. We are actually only going to do tangent. We're not doing cotangent. We're not doing the reciprocal one. We're just doing tangent. And tangent's pretty simple. We're only talking about positive tangents. You'll get into more of this next year in whatever math you're going to take. But when we talk about tangent, again, like I just said, you don't have to worry about cotangent, so you can cross off the bottom. This is what a tangent graph looks like. It's very different from our sine and cosine. You guys see those squiggly things? All right, when you guys do this later on, you're going to graph what they call 3 to 4 time periods. In our case, we're just going to do one. So you're going to be making one squiggly line. But there are some things we have to find. We have to find what's called the asymptotes, and we have to find what's called key points. And it's really, really simple. It's an easy way to figure this out. Now, guys, let's talk about tangent for a second. Remember, if you have an angle that's on the unit circle, you have an x and a y. Your x value is your cosine, correct? Your y value is your sine. If I asked you guys what's the relationship of tangent, you would tell me that tangent is y over x. Everybody should know that. So if you look at this, tangent of x is the same as sine over cosine. That will be handy. Again, I know that doesn't mean anything to you guys right now, but that'll be handy for you in the next couple of math classes that you take. But what I want you to look at from this graph here, in our parent function, what's happening at negative pi over 2 and positive pi over 2? They're undefined. All right, what that means is the graph does not exist at that point. What does that mean for a denominator if something is undefined? 0. Denominator 0. So when we graph, guys, we're going to first find the asymptotes. Asymptotes are these dotted boundary lines that your graph is going to get really, really close to, but not what? Not touch. All right, that's what an asymptote is. It is a boundary line. It's where your function is undefined, where the denominator is 0. So we're going to find asymptotes, and then we're going to find what's called key points. I'll show you how to do that here in a second. All right, domain and range, you don't really have to worry about. We're not going to talk about domain and range as such. We're just going to talk about asymptotes, and we're going to talk about our key points. So you can cross off stuff down here with cotangent. Notice that the tangent is a squiggly line, right? It's a little like snaky thing. It's going to go through the origin in our case. We're not moving left and right or anything. It's going to get close to, do you guys see how it gets close to the asymptotes but doesn't touch it? And the arrow says that it keeps on moving. All right, let's talk about how to do this, what to do. Talk about how to do this and what to do. When you have a graph, kind of like it better to, all right, we're just talking about tangent. So I'm going to say y equals a tan of bx. What is a? What was a yesterday? Amplitude, how high and low. Okay, we're going to equate a with y values. You'll see what I mean by that in a second. But it's how high and low your key point's going to go. How do you find the asymptotes? Okay, everybody write this down. Asymptotes. A-S-Y-M-P-T-O-T-E-S. How do we find asymptotes? You take whatever this value is, whatever the bx is, and you set it equal to pi over 2. And in our case, for what we're doing in this class, your asymptotes are going to be mirror images of each other. So once you find the positive one, the way that you find the negative one is just putting a negative in front of it. After you find your asymptotes, you need to find key points. The way we're going to find our key points, all right? And this will all make more sense here in a second. To find the x part of your key point, you take your asymptote and multiply it by 1/2. The y part is your amplitude. Now I know you guys are like, what is she talking about? As soon as I do one of these, you're going to be like, oh, okay, it's easy. You have to find asymptotes and some key points. And once you do that, then you'll be able to make your graph. So let's go through a couple of little examples here. All right, we're going to graph this right here. Y equals 2 tan 3x. So the first thing I'm going to do is draw a graph. I'm going to put my 0 right in the middle. What's my amplitude? How high and low is this graph going to go? 2. So up here is positive 2. Down here is negative 2. Everybody with me? All right, let's find our asymptotes first. So asymptotes. How did I tell you to find the asymptotes? You take this value and do what? Set it equal to what? Not 2 pi. Pi over 2. Okay? And now we're going to solve for x. Every single time you take whatever that value is behind the tangent, no matter what it is, whatever, just stick it together, you set it equal to pi over 2. So how do I do this? I'm going to divide both sides by what? 3 over 1. Guys, when you divide by 3, it's the same as doing what? Multiplying by what? So it's pi over 2. We keep, change, flip. So where do I have 2 asymptotes? I have an asymptote at pi over 6, correct? You guys see how I got that? Okay, so I have an asymptote right here. I'm going to write pi over 6. And I'm going to draw my dotted line. And I told you that asymptotes are mirrors of each other. So if I have an asymptote at positive pi over 6, where's my other one? If I have an asymptote at positive pi over 6, where's the other one? Negative pi over 6. They're always going to be mirrors of each other. So negative pi over 6. Draw your asymptote. And now we're going to find our key points. For the ones that we're doing, one of our key points is always going to be 0. Always going to be in the middle. Now remember the shape of your graph. It's a squiggly line. We're only talking about positive ones, so all of our squiggly lines are going to be the same. But how do we find the key points? How do you find the key point? What did I tell you to do? Take your asymptote and do what? It's your asymptote times 1/2. Well, what was our asymptote? Pi over 6? So pi over 6 times 1/2 is what? Pi over 12. So here's pi over 12. And what's the other one going to be? If I have one at positive pi over 12, where's the other one? Negative pi over 12. That's it. Now, how do we graph our key points? Well, one of my key points is going to be at positive pi over 12, comma 2. And the other one's going to be at negative pi over 12, comma negative 2, my amplitude. So I have one here, and then how do we connect our dots? Little squiggly line. Always, always, always going to be in that shape. It's always an increasing function if it's a positive tangent. Your dot on the left is always going to be negative. Your dot on the right is always going to be positive for what we're doing. When next year, when you guys get to moving things, shifting them up and down, left and right, that sort of thing, that's going to change. But for right now, you only have to do 2 things. You have to find the asymptotes, and then you find the key points. And those are both fairly easy to do. All right, let's do another example. Ooh, nope. No cotangent, just kidding. Go to the next one. All right, we'll do 1 and 4, and then we're done. 1 and 4, and then we're done. So I say, okay, y equals tangent of 2x. What's my a value? How high and low is this graph going to go? 1. Good. My key point is going to be a positive 1 and negative 1, the y-axis. So go ahead and draw your graph. You're always going to have something at 0 since we're not moving anywhere. So positive 1 and negative 1. Good. Now we have to find 2 things. We have to find asymptotes and then key points. When I find my asymptote, how do I find my asymptote? I take 2x and I set it equal to what? Pi over 2. Good. And then I solve. So when I divide by 2 over 1, this is the same as multiplying by what? 1/2. Good. So I have my asymptote at pi over what? Yep, So I have 1 over here at pi over 4. Where's my other one? At negative pi over 4. And how do I draw my asymptote? How do I draw my asymptote? It's a dotted line because it's not an actual line. It's just a boundary that your graph gets close to and doesn't touch. Now, the other thing I have to find is the key points. How do we find the key points? You take your asymptote, which is pi over 4, and you multiply it by what? 1/2. And I get what? Pi over 8, my key point. So I have 1 here at pi over 8. So where's the other one? Negative pi over 8. And every single time, guys, we're only talking about positive tangents. So it's going to curve increasing the whole way. So you're going to have 1 dot down here at negative pi over 8, negative 1. And you're going to have 1 up here at positive pi over 8, positive 1. And then just connect in a nice smooth curve. Arrows at the end because it doesn't stop. For what we're doing, it's always going to be tangent. We're not doing cotangent. Always going to be positive, and we're not shifting left or right or up and down. You're always going to have that dot at 0. Later on, pre-cal, college algebra, that sort of thing, you guys are going to see some different stuff. All right, one more, and then we're done. Let's look at number 4. Y equals 5 tangent of pi x. Nothing changes. What is my a value? 5, okay? So 1, 2, 3, 4, 5 up here. 1, 2, 3, 4, 5 down here. How do I find asymptotes? I circle that. I say pi x equals, what do I set it equal to? Pi over 2. How do I solve this? Divide both sides by pi, right? So this is like pi over 1, right? So x equals, when I say divided by pi over 1, I keep change what? So I'm going to flip this to 1 over pi. What happens to the pi's? They cancel. So I have an x value. My one asymptote is at 1/2. Where's the other one? Negative 1/2. So just draw 1/2, negative 1/2. And then how do you find your key points? What do you do with your asymptotes? Multiply it by. So 1/2 times 1/2 equals 1/4. So it's going to be here. Where's the other one? Negative 1/4. So I have 1 point at 1/4 positive 5. I have 1 point at negative 1/4 negative 5. And I know I'm always going to go through the middle. And then I just connect. Do not touch your asymptotes. Get close. It needs to be like a curvy little thing. Don't draw a straight line. And that's it. For our tangent, for our purposes, all you have to do is find the asymptotes and the key point. It's not moving left, right, up or down. It's not reflecting, nothing. It's just going to be super basic. And that, ladies and gentlemen, is the end of Algebra 2. All right, next week we'll start reviewing. Ms. Carver's going to put together a big review. I promise I'll go through all of it with you. But you guys do not have another test or a quiz. Makeups for the test. You guys missed it. I'm going to have a makeup on Friday. I don't know when I will have another one next week, but next week is the last to make up anything. If you don't make anything up by next week, it's staying a 0.